Warning, this channel and its contents is for adults 18+. This video is solely for educational and documentary purposes only. I do not condone any illegal activities. Everything in this video is legal, and I do not encourage use. Hello guys. Welcome back. Today's video is different from what I usually post. I'm considering doing mycology alongside my usual content. And in this video, I'm showcasing my startup and how it looks so far. I'll also break down what steps I took to get where I am. Starting from the beginning to now, if you would like to see more of this content, let me know down below in the comments. Here are my master cultures. This is the start for most. From here you can inoculate liquid media to create liquid culture. You could also inoculate grain jars or bags. And you can inoculate all-in-one bags. Basically, this is the start. A master syringe is for storage of a culture. Here, these master syringes are in the fridge, being stored to keep the genetics. This type of storage isn't for long-term viable samples, but can still be used at 1 year with this type of storage. Here is a closer look at the liquid culture. These are more master cultures. Here are my liquid cultures in jars. This is how I was able to take one spore syringe and turn it into multiple liquid culture syringes. These jars are sterilized and sealed. Spore syringes are another start for most. These types of syringes have spores suspended in sterile water. And when you inoculate using these syringes, growth can take up to 2 weeks longer. This is because 2 spores actually have to meet and germinate to start the mycelium growth. Here you can see the mycelium in the liquid media. I use 4% sugar to water. The sugar I use is honey. 100% natural honey is fine, though the color of the media could make it hard to spot contamination. I have 4 strains here. I also have the date of inoculation labeled. You can store a jar like this for a couple months before the mycelium starts to degrade. These jars are stored at room temperature in a sealed environment to increase sterility. If you guys like this content and want to see more in-depth videos, let me know in the comments. I plan on making some how-tos and guides on how I made everything I'm showcasing in today's video. I plan to make videos on my sterilization process and how I inoculate my grain jars, as well as all-in-one bags. I hope you're enjoying today's video, and I want to ask that you like and subscribe. It helps me get better content out to you all. By the way, I'm still a rookie to the whole process. Everything I'm doing is low-tech and budget-friendly. The whole process isn't simple, but not too complicated. You can have your own gourmet or medicinal mushrooms growing at home. A little more information on the process. Different varieties have varying growth rates and growth patterns. In this stage, most look like this, with slight differences. This is about a month of growth. I've already used all of these jars to create the master cultures and to inoculate grain jars I made, as well as inoculate all-in-one bags. Here is a spore print. Think of a spore print as a mushroom's unique fingerprint, a beautiful and intricate pattern left behind by its reproductive cells. The color of this spore print is a crucial identifying characteristic. Some mushrooms leave behind white spores, others brown, black, or even shades of pink or purple. When a mushroom is ready to reproduce, it drops these tiny spores, and by catching them on a surface, we can see their color and pattern. Spore prints can be used to create spore swabs and spore syringes, while most won't begin here. It is a great way to keep genetics and get yourself more well-versed in mycology. Here are my grain jars. I had more of the other strains, but I've already spawned a bulk with those. Think of a grain jar as a cozy, nutrient-rich bed for mushroom mycelium, the vegetative part of the fungus. It's where the magic truly begins. We start with sterilized grain, like rye, wheat, or millet, which is packed with the food the mycelium needs to grow and spread. Sterilization is key. It eliminates any competing bacteria or mold that could harm our precious fungi. Once the grain is sterilized and cooled, we introduce a small amount of mushroom culture, often called spawn. Spawn contains healthy, vigorous mycelium ready to colonize the grain. The mycelium then works its way through the entire jar, consuming the nutrients and transforming the grain into a solid white mass. This process is called colonization. Why is this so important? A fully colonized grain jar is the foundation for growing healthy mushrooms. It's a self-contained, sterile environment that gives the mycelium the best possible start. It allows us to propagate our chosen mushroom species reliably and efficiently. So, in essence, grain jars are the workhorses of mushroom cultivation, providing a sterile, nutritious environment for mycelial growth and serving as the crucial stepping stone for future mushroom harvests. Here you can see these jars are fully colonized and are ready to be spawned to bulk. I'm storing these jars for now as I need more cocoa coir to make more substrate. I use CVG. CVG stands for coconut coir, vermiculite, and gypsum. Think of it as the perfect, nutrient-rich bed for your mushroom mycelium to thrive in. Coconut coir, derived from coconut husks, provides excellent moisture retention and aeration. Vermiculite, a mineral, acts like a sponge, holding onto water and releasing it slowly, which is crucial for consistent humidity. Finally, gypsum, a natural mineral salt, helps to balance the pH of the substrate, making it more hospitable for the mycelium. Here are my shoeboxes. This is another low-tech method. Now, the spawning to bulk part is where the magic really happens. Once your spawn, which is essentially colonized grain or sawdust, is ready, you'll introduce it to a larger volume of your bulk substrate. This is like giving your growing mycelium a much bigger playground to explore and feed on. The goal here is to create an environment where the mycelium can spread rapidly and evenly throughout the entire substrate. Once the mycelium has fully colonized the substrate, meaning it's spread throughout and is no longer showing exposed substrate, it's ready for the next exciting phase, fruiting. This is when the mycelium decides it's time to produce the mushrooms we're all eager to see. We'll introduce specific environmental triggers, like a slight drop in temperature and increased fresh air exchange, to signal to the mycelium that it's time to get to work. Within the shoebox, this transition is quite remarkable. You'll start to notice tiny pinpricks of growth emerging from the colonized substrate. These are the baby mushrooms, or pins. They'll grow rapidly, developing into the mature mushrooms we recognize. Here I'm fanning the lid to increase FAE. It stands for fresh air exchange. Think of it like this: mushrooms, just like us, need to breathe. As they grow, they consume oxygen and release carbon dioxide. If that carbon dioxide builds up in their environment, it can actually stunt their growth and prevent them from developing properly. That's where fresh air exchange comes in. It's essentially the process of introducing fresh, oxygen-rich air into the growing space and removing the stale, carbon dioxide-filled air. This might sound simple, but it's incredibly important for creating the ideal conditions for mushrooms to thrive. Without adequate Fe, you might notice mushrooms that are leggy, have small caps, or simply don't grow as robustly as they could. Maintaining the right balance of FAE is key. Too much, and you might dry out your substrate too quickly. Too little, and you risk those CO2 buildup issues we just talked about. It's a delicate dance, and finding that sweet spot is part of the rewarding journey of mushroom cultivation. This is rhizomorphic growth, also known as rhizomorph. Imagine a network, not of roads or wires, but of living threads, silently expanding beneath the surface. It's essentially what rhizomorphs are. They're specialized structures formed by fungi, acting like the root system of a plant, but with a fungal twist. Think of them as the ultimate underground explorers, designed for efficient growth and resource acquisition. These aren't just random strands. They're highly organized bundles of hyphae, the microscopic filaments that make up the body of a fungus. By tightly packing and aligning these hyphae, fungi create robust, cord-like structures that are incredibly strong and resilient. This allows them to penetrate substrates, transport nutrients over long distances, and even bridge gaps between food sources. What's so incredible about rhizomorphs is their ability to adapt and overcome challenges. They can navigate through tough soil, break down complex organic matter, and effectively spread their mycelial network. I want to take a moment to talk about contamination. Understanding contamination isn't about fear, it's about empowerment. It's about gaining the knowledge to protect your precious cultures and ensure the success of your mycological endeavors. Think of it like this: when you're nurturing something delicate and alive, you want to provide the absolute best environment for it to thrive. Contamination is essentially unwanted guests crashing the party, competing for resources and potentially harming your intended fungal growth. So what exactly are we talking about when we say contamination? In mycology, it refers to the presence of any organism other than the specific fungus you are trying to grow. This can include a wide range of microscopic life forms, most commonly bacteria and molds. These unwelcome visitors can originate from countless sources. Airborne spores are everywhere, floating invisibly in the air around us. Here are my all-in-one bags. I inoculated this one 20 days ago, and the other 12 days ago. Both are fully colonized. Imagine a single, self-contained unit that simplifies the entire process of growing your own fungi, from inoculation to fruiting. That's precisely what an all-in-one bag offers. These ingenious creations typically consist of a breathable grow bag filled with a sterilized substrate, often a blend of hardwood sawdust, grain, or cocoa coir, and a nutrient-rich component like rye or millet. The magic happens because the substrate is fully sterilized, creating a clean slate for your chosen mushroom culture to thrive without competition from unwanted molds or bacteria. The beauty of the all-in-one bag lies in its all-encompassing design. It eliminates the need for separate sterilization steps, multiple containers, and complex setups. You receive a ready-to-go package. Once you receive your bag, the process usually begins with inoculation. This involves introducing your mushroom spawn, whether it's liquid culture, agar wedges, or grain spawn, into the sterilized substrate within the bag. Many bags come with a self-healing injection port, making this step incredibly clean and straightforward. The advantages are numerous. For beginners, they offer an incredibly accessible entry point into mycology, significantly reducing the learning curve and the potential for failure. The contained nature of the bag minimizes the risk of contamination, a common hurdle for new growers. For experienced cultivators, all-in-one bags can be a time saver, allowing them to focus on genetics and experimentation rather than the laborious preparation of substrates. They are also incredibly space efficient, making them ideal for home growers with limited space. However, it's important to approach this with a responsible mindset. While all-in-one bags simplify the process, they still require attention to detail and a clean working environment during inoculation. Always follow the specific instructions provided by the manufacturer, as different bags and mushroom species may have slightly varied requirements. Here's my still air box, aka knockbox. This is used to create a more sterile working environment. Mine is a DIY still air box made from a 64-ounce sterilite box. This is another low-tech method, but it still gets the job done, and it's budget-friendly. Hey guys, popping in real quick to say, while editing this, I decided it was time to put my all-in-one bags into fruiting conditions. I did record and add the recording to this video, as I thought you all would like to see that process. I am cutting vents to allow more FAE in the bags and start the fruiting process. I am doing this in the still air box I just showcased. Now I will finish explaining contamination while you watch me put these bags into fruiting conditions. Little recap. These unwelcome visitors can originate from countless sources. Airborne spores are everywhere, floating invisibly in the air around us. They can land on your equipment, your substrate, or even your hands if proper sterile techniques aren't followed. Think of it like dust, but with the potential to disrupt your entire project. Bacteria are often the first culprits we encounter. They're incredibly diverse and can appear as slimy patches, fuzzy growths with distinct colors like green, black, or even pinkish hues, or sometimes as a sour smell emanating from your culture. Molds, on the other hand, are the more visually obvious invaders. They tend to present as fluffy, cottony, or powdery growths, often in vibrant colors like blues, greens, yellows. The key is to recognize that any growth that doesn't match the expected appearance of your target fungus is a red flag. The impact of contamination can range from mild setbacks to complete project failure. Bacteria can outcompete your mycelium for nutrients, slowing down its growth significantly, or even halting it altogether. Some bacteria can also produce toxins that are detrimental to your desired fungus. Molds are often more aggressive competitors. Their rapid growth can quickly overwhelm your culture, making it impossible for your mycelium to establish itself. The good news is that preventing contamination is entirely within your control. It all boils down to meticulous attention to detail and a commitment to sterile practices. This means creating a clean workspace, sterilizing your equipment thoroughly, and using sterile mediums for your cultures. Think of it as building a fortress for your fungi, keeping the unwanted elements out. And that's all for today's video. I hope you all enjoyed, and like I've said, if you did enjoy, let me know down in the comments. Leave a like and subscribe to see more improving content.